In this question, we're going to do a periodic functions word problem question dealing with temperatures. There's a town in Australia named Mathtown that has temperatures following a sinusoidal curve. The warmest day of the year is usually December 21st, and the coldest day of the year is usually June 22nd. And we want to determine a formula for the average temperature on any day of the year in Mathtown, and then using that formula, we want to figure out what the average temperature might be on August 23rd. So the period is going to be 365 days. Every 365 days, the temperature will come back to what it was before. So we want to know ordinally which day June 22nd is. So keeping in mind how many days are in each of the months and adding them, as you can see here, we see that June 22nd is the 173rd day in the calendar. Now we want to know what day December 21st is. And so adding up the days of the month, we see that ordinally December 22nd is day 355. So what we can see is that the maximum temperature in Fahrenheit is given as 80 degrees. The minimum temperature is given as 30 degrees. On the 173rd day, we're at a minimum, and on the 355th day, we're at a maximum. And the year ends, perhaps obviously, on day 365. Now, there might be a little bit of error in this question in terms of the fact that since the period's 365 days, 365 divided by 2 is not an integer. And so from here to here, we're going to be off by potentially half a day. So in a question like that, like this, we'll live with that sort of an error and just make sure our process is correct. So in a question in which we're talking about a period of 365 days, you can assume that 1 year is equal to 365 and not 366. Okay, so that's the first half of a negative cosine curve. In other words, if that curve keeps on going, we'll end up with a full negative cosine curve going into the next year. So determining some important values here, we see that amplitude is going to be the maximum temperature minus the minimum temperature over 2, which is 25. Since we're using a negative cosine curve, we can say that A will be negative 25. The C value will be the maximum temperature plus the minimum temperature divided by 2, which is 55. The D value will be 173. That's our phase shift. That's how many days into the year it takes for us to begin our next cycle. So K is going to be 360 over 365. And you might ask, why do we use degrees here? It'll be a little bit easier to use degrees than if we use radians and let K be 2 pi over 365. I just like to have a rational number where possible for K. So reducing the fraction for K of 360 over 365 gives us 72 over 73. That's a rational number. I'll use it. And so making sure that we're in degree mode, we'll say that this is our K value. But, if you want to go into radian mode and let K be 2 pi over 365, that's your right as well. And so putting everything together, we can see that our temperature at any day of the year is going to be A cos K x minus D plus C. Okay, and we get our formula that way. Now, in order to answer part B, we want to know ordinally which day of the year August 23rd is. Well, plugging in the days, how many days are in each month prior to August, and then adding 23 for August, we get 235. So what we're going to do is take a 235 and plug it in right here for D, but we're going to make sure we are in degree mode. When we do that, we end up with a value of 42.9. So we can say that on average, August 23rd is likely about 43 degrees Fahrenheit in Mathtown. Now, of course, This is just an estimate based on statistics over time. We know that temperature doesn't necessarily perfectly follow a sinusoidal curve, but discounting things like global warming over a very long period of time, the average on each day does actually follow a somewhat sinusoidal curve.